Motion of a charged particle in a magnetic field. So here you can see the diagram. So this is the magnetic field, the cross or into mark, what you are observing here. This is the magnetic field into the board or into the plane of the paper where I am writing it. So it is starting from outside the paper and entering into the paper. That's what these cross or into mark indicates. In such a field, the charge particle is entering. The charge plus Q is started entering in it. So when a charged particle enters in it, somewhere here it came, does this experiences a force or not? It experiences a force, magnetic force, and that force is given by F is equal to Q into V cross B, right? This is the force it experiences. As a result, it just deflects. In which direction it deflects? The direction of deflection of the charged particle is given by a right hand rule, right? So we have to curl your finger from V towards B. So here the charged particle is moving in this direction. So in this direction, the direction of velocity of the charged particle is here, right? This is the direction of velocity of charged particle. So what is the direction of force? You have to curl your finger from V towards B. For that, I have a right hand rule here. One right hand I will bring it. You just see this one now. You just keep it somewhere here. I will keep it here. I'm curling my fingers from V. V is in this direction, right? V is in this direction towards B. Where is B? B is invert. Invert the plane of the paper where I'm writing it. So inside it. So if you curl it, then where the thumb points in this direction, right? The thumb is pointing in this direction. So when the charge is moving in this direction, it experiences this force. The direction is towards the center, somewhere here, towards the point O. Now this charge came somewhere here because of this force, this particular force. The charge, instead of going straight, it comes somewhere here, it comes, right? So this is plus Q charge came here. So now the direction of velocity of this particle is somewhere here, the direction of velocity. Now again I want to apply a rule, the right hand rule. So this is the direction of V and the direction of B is inward. So now I will bring one more right hand. So I have one more right hand over here like this. I will keep it somewhere here. Now, so the direction of velocity is here. Curl your finger from V towards B. B is downward, right? Inside the plane of the paper. So if you curl it where the thumb points in the direction towards O, somewhere here, right? This is actually the point is inward, the plane of the paper, that is curling from V towards B. Next, as a result of this particular force, the charge, instead of continuing somewhere here, it comes somewhere here, it comes, right? The charge comes somewhere here. So plus Q charge came here, it is started moving somewhere here, it is started moving, the velocity is here. and the direction of magnetic field is inward, that is represented by into mark. Now I will bring one more right hand to get the direction of force. So somewhere here I will come and keep it here. So I'm curling my fingers from V, right? V towards B. The B is inside the plane of the paper. So B. So B is into mark. So where the thumb pointing? The thumb is pointing somewhere here. So wherever the thumb is pointing, you just see the first is here. When the charged particle was here, the thumb is pointing this side. When the charged particle was here, the thumb is pointing in this direction. When it was here, the thumb is pointing in this direction. Similarly, when the charge was here, the thumb points in this direction. When the charge was here, the thumb points in this direction. When the charge was here, the thumb points in this direction. Right? So, the thumb indicates the direction of force, in which direction it is experiencing a force. You see, all the force are acting always towards the center of the circle. And what is such kind of force always acting towards the center? That is center seeking force. Such kind of force is called as centripetal force. Centripetal force. Therefore, this magnetic field itself provides, or the magnetic force itself provides a centripetal force. So the magnetic field itself provides the centripetal force. I will call this magnetic force instead of magnetic field, magnetic force. Therefore, this centripetal force formula is given by m into v square divided by r, where m is mass of the charged particle and v is the velocity of the charged particle and r is the radius of circular path. That is equal to, what about magnetic force? This is the magnetic force, right? Here theta is equal to 90 degree. Wherever you can see the theta is equal to 90 degree. Theta is the angle between V and B. You see, here is the direction of V and the magnetic field is inward. Therefore, angle between them is 90 degree. So theta is equal to 90 degree. So I will write F centripetal force, magnetic force, just magnetic force as QVB sine 90 degree. Right? So why I wrote sine 90 here? Because you know the formula of Q. F is equal to Q into VB sine theta. Theta is equal to 90 degree. That is why I wrote it here. So sine 90 is equal to 1. Therefore, mv square divided by r is equal to QVB. Here this V and this V can be cancelled. Now I can calculate what is the radius of the circular path. The radius of circular path is given by R is equal to mv divided by qb. So this is the radius of circular path, and this is the 3-mark question. They can ask the question like this: derive an expression for a radius of circular path of a charged particle when it is moving in a magnetic field. This is 3-mark question. Very simple steps we used it, and the diagram is also simple. You can use only the right hand rule wherever it is required. Okay, now the same steps here it is there. Okay, you can see this. That's what we got finally. R is equal to mv cross b. R is equal to mv divided by qb. Okay. After this, I want to calculate the period of revolution of the charged particle. Period of revolution of charged particle. Since it is circulating around the magnetic field, what is the time period of that? So the time period or time is equal to, I can use the formula here. You know, the speed is equal to distance divided by time taken. Then what is time taken is equal to, time taken is equal to distance divided by velocity, right? I'm using that relation here. So time period t is equal to distance traveled by the particle. The distance traveled by the particle is 2 pi r, right? 2 pi r is the circumference of the circular path. So 2 pi r divided by v. So 2 pi by v as it is, you keep it. But what about r from previous relation? So from previous relation, r is equal to mv divided by qb. Apply it. So now you just cancel v and v. You are going to get 2 pi m divided by qb. And this is the time period. Okay. Once if you get the time period, it is easy to calculate what is the frequency. You know the relation between frequency and time period. Frequency is equal to reciprocal of time period. So you just take the reciprocal of this relation and write it here. So qb divided by 2 pi m. So the frequency of revolution of charged particle is nothing but cyclotron frequency. The name is called as cyclotron frequency. And all these are 3-mark questions only. You can start from the beginning and you continue all these steps till the frequency, you will get 3 mark. And even the radius is also 3 mark. Okay, easy derivation it is.